Hi everybody, I'm just putting together this week's notes videos. So this is week 3. We are going to finish up our unit on solving linear inequalities, and then later this week I will post in the class notebook as well as the files an assignment for you guys to do. That assignment is going to be one that you can turn in, and I will be marking once you've turned that in. Alright, so what we have here is the following inequalities. So solving inequalities using multiplication and division. Now again, like adding and subtracting, there was the possibility you can add something to one side, you must do it to the other, and if you subtract from one side, you had to do to the other. So just very similar to solving equations. However, there's going to be one thing that you're going to want to remember with multiplication and division is when we see dividing or multiplying by a negative, that there's something really special that you have to do there. So let's just check this out. So what we've got is to consider the inequality. -3 is less than 6. That is true. Yes, true. Okay. We know that if we look at a number line, here's your 0, 6 is probably over here somewhere, and then -3 is lower. So anything to the left is going to be less than anything to the right. So that is true. Now, if I multiply both sides by a 3, and like this question is asking me to, so if I go -3 times 3 and 6 times 3, what that equals is -9 and 18. Well, that is still true. -9 is still less than 18. So true. True statement, right? And then division, if I were to divide both sides by a +3, so let's just consider dividing by a +3, dividing the 6 by a +3. What I do to one side, I must always do to the other side. And so -3 divided by 3 is going to equal -1. 6 divided by 3 is going to be 2. Now, -1 is less than 2. That is true. Simple. All right, now let's look at the following scenario. So when I multiply each side by a -3, we want to ask, is the inequality still going to be true? So if I take -3 and I times that by a -3, and I have 6 times -3, well, I've got -3 times -3. A negative times a negative is going to give me a positive. So we're going to say that that's +9. And then 6 times -3 is -18. Now, this symbol here, if I just bring that down like I do right here, well, this is not true. Because 9 is obviously larger than -18, right? So if we're looking at a number line, here's your 0, 9 is somewhere over here, it's in the positive zone. Anything in the negative zone is going to be over here. So what I need to do to make that true is I need to reverse my sign. So 9 is greater than -18. So now that's true. Okay? And you're going to notice the same thing is going to happen with division. When I divide both sides by a -3, and divide this side by a -3, I get +1 and -2. Well, that's not true because 1 is obviously bigger than -2. So I would need to reverse my sign. So the rule there is, and it's a very important rule, star that, we must reverse the sign when multiplying or dividing both sides by a negative number to keep the inequality true. To solve an inequality, we use the same strategy as for solving an equation. However, when we multiply or divide by a negative, we must reverse the inequality sign. Okay, so we'll just go through some examples now. All right, so just like solving an equation, we're going to divide by a negative. So when I divide by -5 on both sides, well then -5 divided by 5 is just a +1, so I won't write that. And 25 divided by a -5 is going to be -5. And now I just want to make sure I'm reversing that sign. So s is greater than or equal to -5. If we go back to when we were doing diagrams there, s has to be greater than or equal to, so I'll make a closed circle. And then we're going to go so that it's larger. Okay, just showing that. And then I do have, in this case, 7a is less than -21. Divide both sides by a 7. Now, I am taking a negative number and dividing it by a positive number. However, it's not a negative number that's getting divided. Therefore, I don't need to reverse the sign. I will keep my sign the same. It's only when you divide it by a negative number. So 7 divided by 7 is just 1. And -21 divided by 7 is -3. So no reversal on signs in that case. So we've got -3. It is an open circle because we are looking at, there's no equal sign underneath. And we would be going in the direction of a is less than, so it's going to be any numbers lower than. And I'll just emphasize my arrow in that direction. Okay, not a bad idea. Make that a nice fat thick line. Okay. Same idea down here. If I'm dividing a number by -4, the opposite operation would be to multiply that by a -4. So when I do that, that goes away. And -3 times, need to reverse my sign because I multiplied by a negative. -3 times -4 is going to give me a +12. So x is less than +12. Open circle. And emphasize my arrow in that direction. And lastly, we got a two-step inequality here. Actually, not lastly, because we got another example as well. Always start with your adding or subtracting on both sides. So if this is subtracted, the opposite would be to add it on both sides, leaving me with 3x. That becomes 0, less than 30. My sign, if you remember back to the last week, I do not reverse my sign if I'm adding or subtracting. Okay, and lastly, I'm just going to divide both sides by a 3, opposite of multiplying by 3, leaving me with x is less than 10. So I can find 10. Again, it's an open circle. X is less. So we're going to go in this direction. We're going to emphasize my arrow. Okay. One more shorter example. So we've got a +13. So to get rid of that, you're going to subtract it on both sides, leaving me with -4x is less than 33. Take away 13 is 20. then I've got negative 4 multiplied by the x, so the opposite of that would be to divide. Because I'm dividing by a number that is negative, I need to reverse my sign, leaving me with 20 divided by negative 4 is a negative 5, and this side is x. X is greater than negative 5, so I'll find negative 5, open circle, and it's going to be larger, so things like negative 4 and any positive numbers. Here we go. Now we've got some examples that include some decimals as well, okay? And we've got variables on both sides. So we want to get all of our variables together, like terms collected on likely the left side, and then our numbers collected on the right. So when I solve that, what I would like to do is go negative 2.6a plus 14.6, but I need to subtract that. Negative 5.2. If I subtracted the 14.6 over there, I need to do that here. So I'll do some calculations. This 14.6, take away 14.6, obviously gives me 0, and I do not need to write it. So now I've got 2.6a, negative 2.6a is greater than this value here would be negative 19.8 plus 1.a. Now I want to try and get my a values over to the left side. So instead of, it's positive right now, so if I take it away, including the a, now those like terms can go together, leaving me with negative 4.4 a is greater than negative 19.8. With adding and subtracting, it does not reverse your sign. Now, I want to divide both sides by that negative 4.4. I leave the a where it is, so I don't divide by an a either, so that cancels out. But because I had divided by a negative number, I need to make sure I'm reversing my sign. And I get is less than or equal to 4.5. So that's my answer. Now if I'm checking or verifying, now I'm just going to see if this works. Negative 2.6 times 4.5 plus 14.6 is greater than negative 5.2 plus 1.8 times 4.5. Okay, just going to do that calculation there. So this is negative 11.7 plus 14.6. And on this side, I've got negative 5.2. And this side, I get plus 8.1. So just do some more simplifying there. This equals 2.9 on that side. And on the other side, it's 2.9. So we do know that 2.9 would have to be larger than 2.9. Okay, so that made it equal. All right, so then I'm going to go through and I've got just a quick little word problem here. And in this case, choose a variable to write out an inequality. When I write out the inequality, I've got $1.25 and it costs 75 cents for every ride. So I might use R as my variable. Okay. And then he only has $10.25 to use towards rides. So my cost of my rides has to be less than or equal to $10.25 so that I don't run out of money, or I can run out of money but I can't go into debt. So we need to solve that problem by taking away the $1.25 on both sides. And then I want to, that becomes 0. We'll keep that inequality, and then this side becomes $9. 10.25 take away 1.25 is $9. Now I can divide both sides by 0.75. 9 divided by 0.75 is going to equal 12. So he could go on 12 or less rides. Okay, so 12 is okay, 11 is okay, 10 is okay, 9, 8. And so I'll just fill in my graph with discrete dots because I can't go on a partial ride, I can't go on half a ride. So we're just going to fill that in with some dots instead. And I'm not going to go on negative rides. I could go on no rides, but I'm not going to go on negative rides. So I'll leave that with my last dot at 0. And that is it for today. I will post the textbook assignment just below this video, and look for later in the week for a couple of other assignments to come up for review and to hand in, okay? Thank you.